Hemochromatosis and the plague.
So, how does hemochromatosis work? Hemochromatosis is defined as a hereditary disease in which too much iron builds up in your body. There are two different types of hemochromatosis: primary, which is genetic, and secondary, caused by another disease. We'll be focusing on the primary type of hemochromatosis, where there is a defect in your genes that controls how much iron you absorb. Now that I've given you the basic definition of hemochromatosis, you may be wondering how it actually works and the genetics behind it. Since hemochromatosis is genetic, that means you get it from a defect in your parent or parent's DNA that is passed on to you. The culprit behind hemochromatosis is called the HFE gene. As you probably suspected, one singular faulty HFE gene would just make you a carrier for the disease. As a carrier, you don't get the disease, but your children may have a chance. If both parents are hemochromatosis carriers, each child would have a 1 in 4 chance of inheriting two faulty HFE genes, resulting in hemochromatosis. This demonstrates penetrance, something we read about in Survival of the Sickest, the degree that a given gene manifests itself in an individual. Now that we've gone over the actual genetics behind hemochromatosis, we should probably look at side effects and complications. Some complications include damaged joints, diabetes, arthritis, liver disease, and heart failure. Interestingly enough, Malem explains in Survival of the Sickest that his grandfather, who was diagnosed with hemochromatosis, actually enjoyed getting his blood drawn, saying it made him feel energized. This is actually a process similar to donating blood, and it's one of the common treatments for hemochromatosis. It's called a therapeutic phlebotomy. This often occurs every 2 to 4 months, and drawing out the blood in a hemochromatosis patient actually helps remove iron-rich blood cells, lessening the iron in your bloodstream and slowing the effects.
Hemochromatosis and the Black Death connect with each other in a way. Back in 1347, bubonic plague, a fatal disease and outbreak, arrived and spread across Europe. This plague was believed to be brought to Europe by trading ships, as most of the crew seemed to be infected by it. Many people who encountered the plague didn't have a chance to survive, resulting in many fatalities. However, some people did survive the Black Death. You may be wondering how they survived. Well, one answer is hemochromatosis. People who had hemochromatosis led them to have a lack of iron in their macrophages, which are a type of white blood cell that locates infectious agents and tries to get rid of them. However, infectious agents use that iron in the macrophages to feed and multiply even more, and can spread to other parts of the body. Therefore, iron-deficient macrophages helped hemochromatosis patients to survive the bubonic plague, since their bodies could defeat the bacteria and were resistant to it. Natural selection played its role by carrying this genetic mutation of hemochromatosis from those who survived to future generations, resulting in people having hemochromatosis to this day. People with it back then had a better chance adapting to and surviving the outbreak than those who did not have it.
So why does a disease that in itself is enough to kill us continue to get passed down? Research indicates hemochromatosis is beneficial to fighting infection like the plague. If it wasn't, it may not be so common. The plague isn't frequently diagnosed anymore, except for a few weeks ago in California, because we needed more medical issues in 2020. Medical practices used during the plague, such as bloodletting, actually inspired treatments for hemochromatosis, like therapeutic phlebotomy. Although we may not need to fight the deadly disease that killed a big part of Europe long ago, we may be able to apply the same properties to other infections. Think about how this could change our medicines and medical practices in the future. We can even connect this correlation of deadly disease versus infection to other things such as cystic fibrosis and tuberculosis. Our knowledge of disease and its evolution is always changing. Next time you think about how bad a condition may be, question how it may be a benefit to survival in the past, present, and even the future.